students, today's agenda is to check homework. We'll be learning transformations and you will be able to do the second page. Today, students will be able to graph absolute value functions, and it's going to be specifically stretches and compressions. Compressions sometimes are also known as shrinks. But before we start, in here is an example of how it looks. It's g of x equals a times the absolute value of x. If a is greater than 1, meaning this one, it's a 2, a 4, a 5, it's a stretch. And what you do, since it's outside of the absolute value, you multiply the value or the spaces on y. Outside refers to y, inside is related to x. If a is greater than 0 but less than 1, then it's a compression. What this refers is when a is a fraction. If this is a fraction, a proper fraction, then it's a compression, meaning that the graph will shrink. And it will make more sense when we start looking at specific examples. In here it says, graph the transformation of y equals absolute value of x, and then find the value of a. So we can say that a in here is 1/4. Therefore, because it's between 0 and 1, that means that this will be shrinking. And again, I told you that what we're going to multiply, we multiply by the numerator and divide by the denominator. That's how you find the new value. And it's in relation to the value of y. Because to get to any point, you move on x first and then on y. And that's the value that you need to look at when multiplying by that a. Okay, so in here the value of y is 0. 0 times 1/4 is 0, so it stays there. Then the value for this point, the value of y is 1. 1 times 1 is 1, divided by 4 is 0.25, so it's around there. In a minute I'll show you a trick with that, okay, so that you don't have to find these points. The next one is 2. 2 times 1 is 2, divided by 4 is 0.5, so it's around here. 3. 3 times 1 is 3, divided by 4 is 3/4. Okay, 3 times 1 is 3, divided by 4, 3/4. So 3/4 is around here. And in here for this one, the value of y is 4. 4 times 1 is 4, divided by 4 is 1, so it's right here. The way you can do it also is when you have a fraction, just find values for x that are equal to multiples of that denominator. For example, 4, 8, and 12. Even though 12 is too big, then we don't need that. We're going to find 2 points on the right side and 2 points on the left, which will help you create the graph. 4 times 1, 4. Divided by 4 is 1. So when x is 4, y will be 1 now. For the next one, 8. 8 times 1, 8. Divided by 4, 2. So at 8, 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 1, 2 for y. So we're going to have only the 0, 4, 1, and 8, 2. But those are enough instead of having to deal with fractions in here. And that's one side of the graph. Now we have to do the other one. Oops. And I'm running out of ink. On the other side, again, we get the same, but it's now the negative. So negative 1, 2, 3, 4. And we know that it's going to be 1. 5, 6, 7, 8. And we know that it's going to be, can we connect? And that's how our new graph will look. For the next one is a is 3. Remember that we're multiplying. In here it was multiplied, on the other one it was multiplied by the numerator, divided by the denominator. In here is the value of y again, just multiply by that value of a. 0 times 3, 0. 1 times 3, 3. And we start counting from the line all the time. So 1, 2, 3. 2 times 3 is 6. So 2, 1, 2, 3, 4, 5, 6. 3 times 3 is 9. So we start counting 1, 2, 3, 4, 5, 6, 7, 8, 9. We also know that the absolute value is just a reflection on the y-axis. So whatever you have on one side, you will have on the other as a mirror. Okay, so 2 spaces is going to be here, 3 spaces is going to be here, and we connect the points. So that's a stretch by a factor of 3. And more specifically, a vertical stretch. For number 3, we have f of x equals negative 1/3 of the absolute value of x. When we have a fraction, that means a shrink or compression, vertical compression. However, we are also including a negative in here. That's a reflection on the x-axis. It means that whatever is on top, it will reflect down below, but from the shrink. And you can do both at the same time, or you can do one step at a time. So what you do is multiply by negative 1 and divide by 3. Okay, so 0 times negative 1 is 0, divided by 3 is 0. So this one stays the same. And again, if you remember the values for x, a is equals to negative 1/3. That's the value of a. But for x, we're going to choose values to make our lives easier that are multiples of the denominator. So 3, 6, 9, etc. And remember that for the negative values, we just do the mirror because it's symmetrical. We choose 3 first, so it's going to be a line right here. Oops, I shouldn't have put that. So 3 times negative 1 is negative 3, divided by 3 is negative 1. So 1, 2, 3 is going to be a negative 1. Remember, if we did it here, it will be negative 1/3, negative 2/3, but we're deciding, choosing multiples of that denominator, and that will give me whole numbers instead. 6. 6 times negative 1 is negative 6. Negative 6 divided by 3 is negative 2. So when x is 1, 2, 3, 4, 5, 6, y will be negative 2. And then when x is 9, 9 times negative 1 is negative 9, divided by 3 is negative 3. So 6, 7, 8, 9, it's negative 3. It's right there. We know that absolute value is symmetrical, so we go 1, 2, 3, and 1 down. So negative 3, negative 1, negative 6, negative 2, and negative 9, negative 3, and we create our line. Vertical compression or shrink, and reflection in the x-axis. Sometimes what they're going to do is give you the parent graph and also the new graph, and they're going to ask you either for the value of a, or they might ask you for the entire function. So in here, what we can analyze is that it's going down, so that means that there is a reflection. And we also look at the value of y. In here is 1, but in here is 1, 2, 3. So that means that you're multiplying by 3, but a is not only 3, it's negative 3. Negative makes it go as a reflection on the x-axis, and the 3 makes it grow. It's a vertical stretch, okay? So for the function, you can choose any variable for the function. So it can be g of x, it can be d of x. In here, it can vary, okay? And we're just going to put that as the value of a, of the absolute value of x. For the next one, the fact that it's going down again, I know that a will be negative, but then I analyze the values of y. In here, well, it looks like a fraction. I look at ones that are in the corner, like in here and in here and in here. And so I look at those values. For y, the value here was 2, and now it's 1. It's 4. Here is 2. So that means that you're getting half of what you had before, right? If before you had 2 and now it's 1, that's 1/2. If before you had 4 and now it's 2, then it's 1/2 of what you had before. And negative because it's going reflecting on the x-axis. So for my function, let me choose another variable. D of x, right? D of x, this is f of x, this is d of x equals -1/2 of the absolute value of x. So you might be asked to write either the value or the entire function from a graph, but also sometimes they give you the descriptions and you have to come up with the function. A vertical stretch by a factor of 5 and a reflection on the x-axis. So when there is a reflection, you know that a is going to be negative, and a factor of 5, that means it's a whole number. So let's see, let's write w of x. Again, this can be any variable. Is -5 of the absolute value of x. Very simple, okay? In the next one, it says you have a vertical shrink by a factor of 1/4. That means that a is equals to 1/4. There is no negative because there is no reflection. And so v of x equals 1/4 of the absolute value of x. Okay, in this part, the last part of this video, we're going to include several transformations, including the translations that we learned in the first lesson, which is the previous to this one. And so what I recommend when we have the different translations is to analyze what are the values of a, h, and k. And there is one more, which is b, but we're not going to include those in here. A is the value of what we're multiplying to the left of the absolute value of x. In this case, is negative. Since there is no value, that means that there is a -1. H, whatever we add or subtract inside, and that, remember that that moves to the left or to the right on x, is the opposite. If we're subtracting, it goes to the positives, and if we're adding, it goes to the negatives. So in this case, we're not adding or subtracting inside. The value of h is 0. And for k is whatever we have outside being added or subtracted. That's the movements on y, and that one respects. If it's negative, then it goes down. If it's positive, it goes up, okay? So in this case, we have -3. Okay, so having that in mind, another recommendation that I do is, you can do it in any order, but I prefer to do the multiplications of the coefficients, the value of a first. Whenever you have a -1, it just means that it's going to reflect exactly on the other side. So 1 times -1 is -1. We start counting from the line right here. 2, it will be -2, so 1, 2 right here. 3 is -3. 4 is -4. In here, the same thing, -1, -2, -3, and -4. We made that, so those points are not the final graph. We still need to do this translation. This translation tells me that it goes down. It's a vertical translation, 3 units down. That means that every point is going to go down 1, 2, 3 spaces. 1, 2, 3 spaces, 1, 2, 3 spaces, 3 spaces. Or you can just say, oh, well, it's just a copy of that by going down, so you just go from corner to corner. My final graph, so I'm able to graph or connect the points. Some students said, can I just do reflection and translation at the same time without doing these points? And that should be okay, because we're looking for the end result of all the transformations. For number 2, a is equals to 3. H, which is a horizontal translation, is equals to the opposite, which is, instead of -3, is +3. That means that it's going to go to the right, and k is -5. Since it's negative, it's on y, it's going down, okay? Inside is related to x, and it goes opposite of the sign. Outside is related to y, and it follows. It goes up if it's positive or down if it's negative. And this is a vertical stretch. Again, I recommend doing the stretch first, which is times 3. We're multiplying. 0 times 3 is 0. 1 times 3 is 3. 1, 2, 3. 2 times 3 is 6. 2, 4, 6. And it's not perfectly graph, I notice. It should be through here. Yep. My apologies. So this is not the real one, okay? I apologize about that. Okay, so 3 times 3 is 9. So 3, 6, 9 right there. And on the other side, it's just going to be symmetrical. So that would be my new graph if I only had this. However, it says move 3 spaces to the right and 5 down. For every point, I'm going to move 3 spaces to the right. The opposite, instead of going to the negatives, is going to the positives. So 1, 2, 3, and 5 down. 1, 2, 3, 4, 5. Those translations you can do at the same time for both, okay? For this point, 1, 2, 3, and 1, 2, 3, 4, 5. For this one, 1, 2, 3, 1, 2, 3, 4, 5. For this one is 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. 3, 5, and 3, 5. Now I'm able to connect my points. Be careful because you might end up with a graph that is not going through the points that they're supposed to go through. So this is my new graph with all 3 transformations. The last one, A is equals to 1/3. That's a shrink. H, or horizontal translation, is +4. Remember, that is the opposite of what we have here. And K is +3. It means that it's going to go to the right, and this is going to go up. And you know what? To make it more interesting, let's make this 2/3. So the value in here is going to be 2/3. So look at all the previous graphs and see if you notice something in relation to the slope and the rise and run, okay? If this was my rise and my run, it means that it would go up 2 spaces and then 3 to the right, okay? Okay, so remember that when there is a fraction, we're going to find values or use values for x that are multiples of the denominator. It doesn't matter what you have in the numerator. So it's going to be 3, 6, 9. But let's start with 0. 0 times 2 is 0. Divided by 3 is still 0. So that point stays there. Now let's do 3. 3 times 2 is 6. Divided by 3 is 2. So whenever x is 3, then the y value is going to be 2. Okay? Again, why? Because 3 times 2 is 6. 6 divided by 3 is 2. Now let's look at the value of 6 when x is 6. 6 times 2 is 12. 12 divided by 3 is 4. So 6 on x and 4 on y. 9 times 2 is 18. 18 divided by 3 is 6. So when x is 9, y will be 6. And on the other side, it's going to be just symmetrical. Symmetrical, it's on the same. So -6 is 4. And -9, it's going to be... So something, since we're doing that first, Remember that the rise and run will go 2 up and 3 to the right, 2 up and 3 to the right, 2 up and 3 to the right. Okay, now we have that transformation done. From those points, we're going to move 4 spaces to the right and 3 up. Every point will move 4 spaces to the right and 3 up. So this is my vertex. And from there, you can actually just copy the rise and run. 2 and 3, 2 and 3, 2 and 3, or count every point. I did that one, so now it's 1, 2, 3, 4, 1, 2, 3. Or count from this vertex, which is this one, count the slope. 2 over 3, 2 over 3, 2 over 3. Okay? Or just start moving each one individually, 4 spaces to the right, 3 up. The next one, 4 spaces to the right, 3 up. The next one, 4 spaces to the right, 1, 2, 3, 4, 1, 2, 3. Each point, 4 to the right, 3 up. This one, 4 to the right and 3 up. 4 to the right, 3 up. 4 to the right and 3 up. Or again, since it's 2 and 3, 2 and 3, 2 and 3 for the rise and run, then you will go on the other direction just because it's a reflection. Now that we have our points with all 3 transformations, we can connect our points, and that's going to be our new graph. With this, we end our lesson. If you can please give us a thumbs up, subscribe around here. This is the link to the entire unit, and here you will find the next lesson. Now you're able to do the second assignment and have fun.